Hello, game theorists. We just finished playing our collective action game, so let's talk about the results. This is actually not one of the games where I'm pitting your self-interest against your urge to cooperate. Cooperation here is actually part of one of the Nash Equilibria. So there are two Nash Equilibria. Let's figure out how both of them work. The first Nash Equilibrium is where nobody donates. So if nobody donates, then n is going to be 0. So everyone's getting a payoff of 0 squared, which is just 0. If your group switches to donate, that is going to make them worse off, so you wouldn't do it. Let's check. So instant number of groups other than your own, which are donating. So if nobody else is donating, you're donating, n is 0. So your payoff is 0 plus 1 squared minus 12, which works out to negative 11. So if no one else is donating, you could get 0 from not donating, or minus 11 from donate. So if everyone else is going to not donate, you're not going to donate either. So that's one Nash Equilibrium. Now notice the payoffs here get bigger and bigger the more donors you get. So the other Nash Equilibrium is where everybody donates. So there's a total of 8 groups, and there's a number of groups other than your own which are donating. So if all 8 groups are donating, then you have 7 groups other than yours which are donating. So n is going to be 7. So if you join in and donate as well, you get 7 plus 1, which is 8. 8 squared minus 12, so 64 minus 12, which works out to 44. So, no, 54, sorry. You can get 54 by donating if everybody else donates. If you decide to not donate, there are still 7 groups other than your own which are donating. 7 squared is 49, and 49 is less than 54. So if everyone else is going to donate, you want to donate. If no one else donates, then you don't want to donate either. Those are the two Nash Equilibrium. So a common question I get in class is that I show some game which has 2 equilibria, and one is clearly better than the other. A lot of times people say, well, in real life, if this game were to happen, wouldn't people just go for the good equilibrium? And the answer is, not necessarily. Bad equilibria sometimes do come up in real life, and it really would be better if we could get everyone to switch, but trying to get everyone to switch at the same time doesn't always work so well. Doesn't always happen. I gave a couple examples in the earlier videos, like I mentioned the example of the keyboard. So the keyboard we have here in America with a QWERTY setup actually slows you down when you type. It's not optimized for typing speed, but that's how we all learn how to type. We're all used to typing that way. If some company came out with a new keyboard that was optimized for typing speed, probably no one would buy it because we've all learned the old way. Another bad equilibrium I talked about was the metric system versus the US system. The metric system is definitely easier to use, but it's an equilibrium where if everyone else is using the US system, then you want to use the US system too. So likewise in this game, even though both donate and not donate can be part of Nash Equilibrium, you can't always assume that we'll coordinate on the good equilibrium. So here's what happened in this class. So we got 5 groups that donated and 3 groups that did not. I have some past results from other courses. So in the fall, the class was also all online, and we still got a reasonable amount of cooperation. I think we had 6 groups out of 8 that chose to donate there. One theory I was looking at was possibly that the online classes could be less personal, so perhaps that could feel less cooperative. But if you compare this game to what happened in the spring of 2020, which was face-to-face for the first part, then switched to online during the pandemic, that class was actually less cooperative. So we're there in spring 2020. I think only one or two groups picked donate, and the rest all picked not donate. So they were getting close to that bad equilibrium. So I haven't found a real correlation between online versus face-to-face in causing more or less cooperation or not. But in any case, the moral of the story is that you can't always assume the good equilibrium will occur. Sometimes, in like one of the previous courses, we coordinate on the bad equilibrium. So that's all I have for today. Best of luck on our upcoming midterm. Take care.